So this first talk is basically on what functions do you actually need on your machine in the office. Because some people go to buy a machine and the trade can be quite persuasive, and you might end up with something either A, doesn't suit your needs because there is not enough functions on it, or B, a huge machine that has cost you 3 times what you wanted to pay and you hardly use it. So what we're going to do is I'm going to go through some functions, and as I talk about a function, we have Tracy at the back there on the machine, and I'm going to be hitting a switch and she's going to actually be showing you the functions as we go along. So first of all, if you can just understand that the basic principles of the ultrasound is that the transducer is going to emit that short pulse of ultrasound and then it waits to receive the returning echoes. And that time between leaving the transducer and the return is directly proportional to the depth of the reflecting structure in the body. So if you have a 150 kilogram woman, it might take a fair bit longer than a very thin lady. And thus the need for different transducers, our 2.5 megahertz as opposed to our 10 megahertz. So the lower the frequency, the deeper it's going to go into the body. So that transducer converts the electrical energy into the ultrasound energy and vice versa. So when that electrical signal is applied to the transducer, it creates the ultrasound pulse, which is transmitted into the patient's body, and those echoes from the body return to the transducer and converted back to the electrical signal. And you'd be surprised how many users of ultrasound just don't understand the very basics of it. I can't stress highly enough that transducers are extremely fragile. They will probably take up more than half the cost of your equipment. So please treat them very, very carefully. Wipe the gel off when you're finished, and if they're not in use, just keep them covered. So we've got a few different types of transducers that you can use. We have our sector or our curved array like this one, which is the most commonly used for the obstetric. So the beam is perpendicular to the transducer face, but it's stepped along the face and it follows a radial path. So the scans are partially sector shaped. And Tracy, have you got one of those plugged in? Yes. I'm just going to switch across. So this is the sector, and you can see at the top how it's curved at the very top of it. So the advantages of that is that there's multi-frequencies, a very wide field of view, and quite good penetration. Then we have our linear transducers. Now the linear is a flat-faced. You probably wouldn't use it too much in O&G, although if you're doing a lot of gynae work on young children and everything, this is very good for looking at ovaries. And also a low frequency linear array is excellent for when we're looking at very early pregnancies on very, very thin ladies. So it's got very high resolution. Don't worry, plugging that in, Tracy. Then, of course, we have our transvaginal probe, which we should be using on probably every patient that we're scanning in the early parts of pregnancy, and certainly with your gynecology. And this afternoon you'll have the opportunity to actually work on some phantoms with them and ask us any questions. Now the keyboards, every machine is different. And please read the instruction booklet before you start using your machine. Most equipment companies will offer you the use of an applications person to come in and actually train you how to get the best out of that machine. And it is worth spending at least 15, 20 minutes, half an hour to go through all those functions on the machine. Every machine is different, as I said, and sometimes it's like driving a jumbo jet. You might walk into one room and you've got a keyboard like this one. And then today we're working on simplified systems. So every machine is different. Now, our depth control, usually when you turn a machine on, I've seen so many people not adjust anything. We have our depth, and that will accommodate the body part that we're looking for. So if it is a very superficial organ, or say a very early pregnancy on a young lady, that could be very, very superficial. Or it could be very deep if we have our large lady, third trimester, and we're looking at something on the posterior wall. We need to adjust our depth accordingly. And if there's a control for sector width, we should be using that as well. Now I'm just going to flick across, Tracy, to show, so you can show them the depth and the sector width. So watch what happens when she adjusts that. You can see we're coming up to the near field. And if you look at this control just at the side, what we call the focus, there's a little arrow at the side there. That's the focus. And do you have sector width on that, Tracy? And sometimes if you're looking at a very early gestational sac, it's worthwhile bringing your sector angle straight in and also adjusting your depth. Now the focus was what Tracy just showed you with that little arrow, and that's always important to move that to either just below or on the organ that you're looking at. So whether it's a fetal heart or the gestational sac or a leg that you're trying to optimise. So that identifies where a given echo has come from, and the machine needs to know the depth of the reflecting structure. So the direction can only be determined if the ultrasound beam is relatively narrow. And all of these new transducers these days are actually focused. And an unfocused transducer can't achieve this, and so you can't focus anything. We do get that on a lot of the older equipment that's been donated overseas. So sometimes if you're working on an outreach program, you might find some very, very old equipment. Now next is the gain control. So that corrects for the attenuation of the ultrasound as it passes through the tissue, and that can be an overall gain or a gain in a particular spot. So what I'm going to do here, this can make your image either too dark or too bright. And I'll just flick back. And Tracy's going to turn the gain right up now, the overall gain. And you can see what happens. It's unreadable, really. Now, if she adjusts the toggle switches that you see at the side, this is our TGC, and again, you can make an image look quite bad or good. And sometimes one of them might be moved right across to the left, which leaves streaks in the image. So it's important to try and keep those list of toggles even. Thank you, Tracy. So the next thing we're going to look at is whether a machine has got zoom functions. It's really good to take a closer look at anatomy. So on that top image there, we've got the overall view of the uterus or the baby. But then if we want to blow something up to maybe have a closer look at an endometrium and you've only got the trans-abdominal probe, this is where a zoom control is very good. A right zoom means that on some machines you can freeze the image and then zoom it up, and on others you can actually adjust the depth, focus, gain and sector first, and zoom it while it's still moving, and this is called a right zoom. And that's preferable because it gives a much crisper image. So I'll turn back to that now. And Tracy's going to show us a zoom control. And this is called a right zoom because she's actually bringing it in on the image. So you can see a big difference there. So if you're trying to highlight something, whether it's a defect, it's better off to use the zoom control. Thank you, Tracy. Now the next is measuring. A good machine will have the ability to use multiple calipers simultaneously. So in other words, we want to measure the length of a retroverted uterus, and we might do that in 2 stages. So 1, 2, or we might want to measure multiple follicles in multiple planes. So we can do that. So some machines might have 1 measuring point, some might have 2, some might have 8 or 10. Now also with the measuring, if we can have a volume measurement, that is very, very useful if we're trying to do a follow-up on a patient that has fibroids, or looking at ovaries, or looking at some mass. So doing a volume is much easier for, let's say if you're putting in a report, by the way, the patient has a fibroid measuring 4 by 3 by 2. If you put the volume, say, is 6 cc, it means that if that patient goes somewhere else to one of your colleagues, they might measure slightly differently, but they might see if they get 6 cc, 10 cc, 12. In other words, has that lesion shrunk or grown? So I'm just going to flick back across to Tracy, who's just going to show a couple of measurements now. So as we freeze an image and just putting on multiple measurements onto it. So let's say you're measuring how much amniotic fluid is in there, or femur length, or anything like that. It's really handy. So if you could just do a couple of measurements on the same screen there, Tracy, for me, of straight measurements rather than biometry. It's all right, we'll just flick on to the next one now. M mode is also good, naturally, to look at your heartbeat. And it is good if you can measure it over more than 2 cycles. So preferably 4 cycles, and a lot of the equipment you can actually adjust how many cycles you want to measure over. Split screen is also good. The ability to, say, look at a transverse image and then a longitudinal image, particularly if you want to do a volume measurement, say, of an ovary or of a mass. That's very useful. And also colour. And the colour, can we pop it on to have a look to see if a cord is wrapped around a baby's neck, or to see if there's actually a heartbeat. If you're not sure and you can't see a heartbeat, no matter how well you've optimised the image, just before calling it a fetal demise, put the colour on. And if you're putting the colour on, the important thing is to make sure you are over the myometrium as well. If you have colour in the myometrium, but not in the fetus, it means that your colour settings are correct. So if there was any heartbeat, you should see the colour within the heart as well. So don't just put this colour over the fetus, it must go over the myometrium. Colour's also useful if you're looking for umbilical cord, the vasa previa, etc. so to move it over the head. 3D, 4D, it's not common on point of care systems, very limited value apart from very pretty pictures, and usually not available on your small systems that you buy. Doppler, it certainly does have its uses. It can be an advantage if you know how to work it properly and if you know what you're reading, if you know what the results mean, but it's not really essential in the office system. Other factors that you need to consider: image quality, especially when assessing those very small fetuses that are only millimetres in size, application backup when necessary, and the cost versus reliability of spare parts, and most importantly, the ease of use. Someone might say, well, that machine's going to cost me $50,000, but they have a really good service department, really good people, really good machine. Another machine might give very pretty pictures and cost $10,000 or $15,000, but maybe not so reliable. And some people say, well, it's like a car, the Mercedes versus the Cherry, or something like that, where if it breaks, you throw it out and you buy a new one. So there's lots of things to consider, but what we're going to do now is Waldo is going to do a scan, and I think it's a twin pregnancy, and he's going to be describing what you go looking for. So thank you and enjoy your day, and please ask us any questions that you've got.